Okay, thanks for coming, everyone. In the first section, Jingha gave a great introduction to the D2S using the web platform. So in the second half of this section, we're going to introduce how to use Python to access the data programmatically, and also how to use AI to extract information from the data. And you can scan the QR code here to get access to the Jupyter Notebook. And we're going to walk through each individual step to show you step by step how to do visualization and also how to do geospatial analytics. The URL is tinyurl.com, canvas, all uppercase, hyphen 2025. And then it will take you to the website. So we're going to use Python, and I know earlier Jingha already asked how many of you use Python. Looks like a relatively small minority, so don't worry. It's very low bar. You don't even need to know programming. All you need to do is know how to click the buttons, and so later if you want to learn more, you can dive into it. But for this workshop, you can just follow me through. And everything we're going to cover here is reproducible. That means if I'm getting the result, you will get the same result. So we're going to use the notebook to show you how to stream the data, how to visualize the data, how to analyze the data, and then how to get results out of that. So you all have access to the QR code and the notebook. So it should take you to the website here. And it's called GeoAI. So this is a package that I created to make it easy for people to apply AI on geospatial data. And so all the drone imagery is part of the geospatial data. And for today, we're just going to cover a small portion of the functionality of the package. You're welcome to check it out. It's all free, open access, and open source. I only started working on this one maybe less than half a year. So it's still pretty new. It's still under active development. There will be a lot of new features. So if you interested in learning more about the source code, you're welcome to go to the GitHub webpage. You will be able to see all the source code if you want to learn more about things under the hood. And so for this workshop, I'm going to show you here. If you click the webpage, it should take you to this webpage here. And for those of you with no Python programming background, the easiest way to use is to use Google Colab. So what you need to do is just go here, right-click this icon, open in Google Colab, and then click the first one, open link in new tab. Then it should take you to the Google Colab. And how many of you have heard about Google Colab or used Google Colab before? Okay, good. So maybe 30–40%. And so Google Colab basically is an environment that allows you to write Python code, and then you can have text, you can have description, you can have code. So you can have everything within the same notebook. And it's very powerful. It's the one, yes? Oh, yeah. Let me see here. Yeah, actually this is 150%. So is it better? Or I can go a little bit more, 175%. And so what you need to do is to log into your Google account. You definitely need to have a Google account. And you can also, if you want, you can copy this one to your Google Drive. So basically, think about Google Docs. You can think about Google Docs, but it's for programming. And once you connect to your Google account, you can see upper right corner here. It says connect T4 or something like that. If you want, you can click that if you want to, or later when we run the code, you will create. So basically, under the hood is Google is going to create a virtual computer, allow us to run the Python code. And don't close the tab, okay? Once it's closed, it's gone. If you close it, reopen it in maybe in 10–15 seconds, you will come back, but within a minute or two, you'll be gone. It's going to be destroyed. So it's just a virtual environment in the Google Cloud. So here, log into your Google account, and if you want, just click connect to T4. Then it might take a couple seconds. It's going to basically assign. And once you see the green check mark, you can scroll down here to see. Oh, you even have the GPU. Oh, by the way, so if you don't see that, let's go to here. Runtime. Click runtime and then change runtime type. Because we're going to use AI, so you need to have access to GPU. So here, select the second one, T4 GPU. Okay. Once you have done it, just click save. Then it should have access to the GPU. So you need to make sure that you have this one. You want to have 3 dashboard here. You make sure you have the GPU. So this one is 15 gigabyte. It's probably better than most of your laptop here. Most of you don't have 16 gigabyte GPU on your laptop. So it's I think okay for the workshop, but if you're dealing with large amount of data, then you will need more GPU. But this is free, so it's great for using during the workshop. And so there are a couple of things I want to quickly go over, especially with a new. On the left side here, upper left corner. Yes? One more time. So here, go to runtime, and then change runtime type. Okay? Select the second one, T4 GPU, and then just click Save. You should, upper right corner here, if you don't see the green check mark, click the button again, and then you connect to GPU. So if you can see this one here, that means you are ready to go. If not, let me know. We can pause it. Yes? Here, the runtime. Here, this one. Oh, if you click here, upper right corner, if you click this button, it should open this tab here. So this is free resource. It says you are not subscribed. That's fine. Okay, it's enough for this workshop. But if you use every day, then eventually you need to pay. GPU is pretty expensive, just like ChatGPT. It's enough for small amount of work, but large amount of the access, then you need to have that. So later, you might run into issues that you're going to say the GPU exceed the amount of available, then you need to restart the kernel so that we can do it. But I've tried it. It's enough for this workshop. So hopefully no issues later. On the left side here, if you click this button, the sandwich icon, the 3 line, that one is the table of content. So just like the Google Docs or Microsoft Word document, that allows you to go through. So we have different sections in here. It's a pretty long document. So later, if something goes wrong, you can go back, you can jump to individual section. So basically just the headings makes it easy for you to navigate through the notebook. The other one I want to show you is lower left corner. There's a folder icon. So this is the one that have all the files that later you're going to generate. It's going to be downloading the files to here. So you can click here. So think about this is the virtual computer. So the files saved temporarily on this virtual environment. If you close it, it'll be destroyed and gone. So don't close the tab, make sure. And that's it. So after that, you can just start walking through the examples. I'm going to show you step by step. There are a couple links in here. So we're going to cover using a couple more packages. Leafmap. So there's a package that I created a couple years ago for visualizing geospatial data in the cloud. We use some of those for doing like interactive mapping. There's another one called SAMGeo, so allows you to basically run image segmentation on satellite imagery. It's called Segment Anything model from Meta, Facebook, and it's very powerful. It's a foundation model, allows you to extract information. So we can use that to extract trees, buildings, all kind of stuff from satellite imagery, and then the GeoAI. So the focus will be using the GeoAI. We can train our own model, and then we can extract information. So hopefully after today, you can claim that you know how to use AI to extract information from remote sensing imagery. It's pretty easy. So I simplify a lot of steps, makes it really easy. All you need to focus is where's your data, and then you can just plug in, and then a couple lines of code, you can train the model, and then you can get the information. And everything's interactive, so you can see the data interactively, see the result interactively. All right, so that's pretty much the introduction. And so what you need to do here is first step is to install all the packages. So for the notebook example here, this is so-called the code blocks. On the left side, there's a play icon. So that one basically is like running the code. So if you click the button, accept like run anyway, okay? And this one might take a couple minutes. This one is the time-consuming part because you can think about is setting up a new computer, install all the requirements, the packages needed for this workshop. It's just like you getting a new computer. You need to install Microsoft Office or any software you like. And just be patient because some of the packages might kind of getting stuck for a couple minutes. Those are some of the AI like large dependencies. So you're basically building the dependencies and it might take a while. So just keep it open. Like I said, maybe 3 to 4 minutes. It should be done. Yes?
What kind of AI are you using? Are you using the ChatGPT
No, it's not. It's not ChatGPT. It's called GeoAI. It's the Python package. So if you go here, so this is the package we're going to use. So it's called GeoAI, and you can install using pip install, or it's here. So if you go back to this one, if you scroll up, you can see these are the packages. So GeoAI Pi, yeah. So this is the one we are using, and we also use the SAMGeo too. And yeah, so these are all those 3 packages that I created. GeoAI is the most recent one. SAMGeo was the previous generation, but it's still pretty powerful. So we use these 2 for doing AI, and the first one is for doing data visualization, interactive map in the Python environment. And let's see. Yeah, just wait until it's finished. And other than that, you can see, you can scroll down, you can take a look of the data. So we're going to cover how to create interactive map, and then how to query data from the D2S platform, and we can visualize data interactively within the Jupyter Notebook environment. Then we can start doing some visualization comparison. After that, we're going to download some data. Then we're going to basically apply image segmentation to extract trees and features from the imagery. And the last section is to train our own AI model on the imagery. If you already have some training data, and we can apply your training data. So basically, the second one is called segment anything model. Basically, you don't need training data. It's going to segment everything, all the objects within the imagery. So you don't need training data. It's kind of similar to remote sensing unsupervised classification. But the last one is called GeoAI, is that we're going to train our own model, providing our own data. Don't worry, it looks like a lot of technical stuff, but it's very easy. Once we get into that, once you see the data, see the result, you will know what we are talking about. And so for those of you who want to set it up on your local computer, you are welcome to. But like I said, unless you have GPU, this is going to be very slow. So in terms of runtime, if you're trying to use the same workflow in a laptop without GPU, usually it's 10 times slower. So for example, what we're going to use here might take 1 minute. For your laptop, it might take 10, 15 minutes. So certainly GPU is going to be very helpful in cases like this. And yeah, it's making progress. So hopefully you're going to see it's install build dependencies. The lower right corner here, you can also see the executing, how long it's executing. So hopefully no error, and then we can move to the next step. And this is all free open access, so you can go back after the workshop. You can come back to the workshop again, and then you can open it again. So you can, but it just need to reinstall every time, because it's a temporary computer. It's not permanent. So once you close the tab, you'll be gone. And if you use this like constantly, then you better install the things on your computer so that you don't have to install all the time, every time. So let me see. Hopefully it's done. Okay. Oh, is it got disconnected? Oh, here. I think this one. Okay, it's here. Anyone finish this step? Yes? Okay. And so afterwards, I'm going to switch to my Jupyter Notebook environment. Is the same. The interface might look slightly different, but it's the same stuff. But I'm going to use my local Jupyter Notebook, so it's going to be a lot more smooth. But you can use the same. You just follow through, click the buttons, you'll be fine. I'm running this on my laptop, but it's connecting to the server in my office. So I have a much larger GPU, so it's going to be much faster. When you're running, once I'm done, you might still be waiting. That's fine. It's just I'm using a better computer to run the analysis. So, okay, I think we're almost there. Yes? Can you increase the font size for you? Say it again. Increase the font size. Oh, increase the font size. So let me come back to here. 175%. Is it a little bit better? Okay. And so now let me switch to here. Hopefully. All right, it's done. So nice. No error, nothing. So they were good to go. Anybody all finished or still waiting? Could you please wait a little bit? Okay, wait a little bit. That's fine. So for those of you who are already finished, you can just scroll down a little bit. Like I said, don't worry if you're still waiting. No worry. Click this one. Make sure that you can import the library without problem. So I'm going to use leafmap, and so you can scroll down, and click this one. You can close this tab here, and then click this map. If you can see the map, that means you are ready to go. So I'm going to go back to my notebook here. Let me do the same thing. And you will see here I don't have to install again because I have already installed it on my local computer. But hopefully, I will give another minute. Hopefully everyone finish. Yes? So in the flip, some packages you were mentioning codes. Say that again. So in the flip function. Pip function here, you mean this one? Two of them were in codes. Like two of them, two of the packages you mentioned inside the codes. I cannot hear. Leafmap and segment geospatial were mentioned in codes. Not mentioned in code. Oh, mentioned in the double quotes. Oh, basically means they have some optional dependencies in there. So if you just install leafmap, there are some other dependencies not in the leafmap core. So you have some optional dependencies. So this is basically just the Python packaging kind of a convention. So if you, for example, in here, let me show you quickly in leafmap. Let me zoom in a little bit here. So this is the leafmap package. So the core package only have these dependencies, but you can install some optional dependencies. So that's why it's like in double quotes, because inside there's like the project toml file. Inside here, it defines what other dependency will be installed beyond the core one, because you don't want to put everything, install everything like unless it's really necessary. So for most users, they don't need this. But for this workshop, we need this. And so the raster, like basically is the identifier here. That means we're going to install the leafmap in addition. In addition to leafmap, we install all these packages. Okay, all done? Yes? Okay, then we can move. Yes?
There are some third-party widget errors.
Oh, you can just click on the left side, just close it. Yeah, you can just skip it. If it pop up somewhere on the left, you can just close it, don't worry. And the other thing I would recommend is to, once you finish installation, there should be somewhere here, like on the left side, it shows like the, I really finished it, but there should be a drop-down list somewhere here. And then if you click the drop-down and then it says clear all the output, so in that way, it doesn't have like too much content, so it's kind of overwhelming. It should be on the left side somewhere. Do you see that? And then after you finish, there should be a drop-down list somewhere to clear the output. Yes?
We closed it, but still not working. It still says that the third-party Jupyter widget.
1 second. Okay. Anybody else can see the map? Yes. Okay. Oh, here you can just close it. And yeah, if you forget about, you don't need to run all of this, just click one. Yeah, yeah. Yeah, that one is a bit annoying. It's kind of a Google Colab, they have some security issues. All right, so you all see the map? If not, let me know. Otherwise, you will not be able to do anything. You will just watching. So once you have the map done, I'm going to go here. So this is basically just a simple map, a global map, nothing fancy, but I'm going to put data on top of that. And I'm going to quickly go to maybe run the next one. So the map is customizable, so you can center the map at a certain location. So right now, I'm creating a map center in the US. The first one is the latitude. The second one is the longitude. Okay, so 40-degree latitude, negative 100 longitude. Make sure you don't switch. Some packages use longitude, latitude. Some packages use latitude, longitude. It's very confusing. But for this is based on leaflet. So it's using this convention. And the zoom level is how much you want to zoom into. So it usually ranges from 1 to 26 or 30. So the larger the number, the more zoom in to that location. So you can change it. For example, zoom to like zoom level 9, and then you can just run again. Or on the left side here, you can just click this one here. You can rewind this code block, okay? So you can run it multiple times, it doesn't matter. So I can change this one to maybe 8 or something. So the larger the number, the more zoom in. Again, if you see this pop-up widget, just close it. It doesn't matter. And you can zoom in, you can zoom out. Upper right corner here, this is a toolbar, allows you to change the opacity. So if you click here, and you can see a lot of tools in here. We don't use them today, but the one that you might want to use is on the left side here, click layer. So this sandwich icon, if you click this one, and you will be able to see the layer control here, allows you to change the layer opacity and also the visibility. So you can check the box, it's going to hide it, and the slider here allows you to change. So later when we have multiple data layers, then you might want to see like the top one, the bottom one, and you can see on Google Colab, it should be working, but it's not as smooth as something that I run here on my local computer. So if you see this one here, it should be a lot more responsive. Right. So this is the map, basically just create a map. And you can also add base map. For example, you can add other satellite-based maps, so the Imagery world imagery. Yes?
I don't think I have to fix them.
Okay, let me take a look.
It's the same issue, but
Here?
yeah.
So I run the library,
Uh-huh.
and then if I come down and run, it still doesn't pull.
Oh, you need to.
I ran that, and it still keeps pulling this.
That's interesting. On this one. Oh, you disable it because you So let's do this. Runtime, restart section,
Okay.
and then just you don't need this.
So I didn't put that
Yeah,
in there. That
yeah, it's automatic. Sometimes it's a little annoying. So then let's try this one again. Hopefully it works. And don't just ignore it. Yeah,
Okay.
just close it. Yeah, just close it. All right, so this is the satellite-based map. Again, you can zoom in to it. It's going to load the data based on the zoom level, so it's pretty high resolution. And you can also add other base map. So here, if I run this one, you might need to scroll up back to the map because the M basically that one is the variable name of the object. So you can display the object in multiple cells. So you're going to create multiple maps. But if you don't display it, so in this block here, I just add a base map. It's exact to the map that we display in the previous code block. Okay. And you can also add other tile layer. For example, I can add the Google base map, and then you can scroll up. So you can bring a lot of data layers from other places. And you can even have the base map like GUI allows you to change the base map interactively. If you run this code block on the left side, on the right side here, it will show you all the maps available. So you can use whatever base map available. So for example, I can change it to National Geographic, CartoDB. You can play with it. It's some of the data, basically these are all open access, so you can use whatever you like. For example, I can try the US National Land Cover Database. Right? And once you're done, you can close it if you want to. So this is very simple. Just create a map, a couple lines of code, and it's all interactive. The next section, I'm going to basically pull the data from D2S, and then so you can see the data within the notebook environment, so you can run analysis on top of that. Any questions so far? Right? Easy, right? You can just click the buttons. If you want to understand the code, you can, but they are all very simple. You can just read it. You will be able to understand it. So next, let's start getting the data from D2S. So first, you need to import these libraries. Just click the button. And so this is where you will need to change that to your email that earlier when you sign up. So change this one to email. This is my email. If you just run it, it's not going to work. If you already run it, you can click the button here to interrupt it. So if you accidentally already click that, if it is asking the password, you can just click the stop button on the left side. Then you can redo it. So for me here, I will just run this one. Oh, because I already set it up on my, the second one. Second one is going to ask you the password. So if you click this one, you should see the input box. Do you see that? Yes. So change that one to your email, and then I can just enter my password here. Let me see. Hopefully it works. If it doesn't pop up again, that means your password is good. Any problems? Yes?
Yeah, it just seems like I'm using the right credentials, but it's not.
Let me. Do you change that one to your password? Anybody having the same issue? Can you enter the password? Is it working? Not working? Yes? Okay.
That means that that's not correct password. Is this the
You see the password? You don't have the ad.
Keep asking me to enter my password.
No, you need to have your email, right? It's not just your username. It's your something at.
That's my email.
Okay.
This is the correct credentials.
That's weird. Yes? Mm-hmm.
So I enter my password here,
Uh-huh.
my email right here.
Uh-huh.
Then
You run the first one here. Click this. And then run the second one.
second one,
Uh-huh. And then enter your password.
the email password that I created.
Yeah. The one password you use for the account. Yes?
In my case, it's like they are loading
Uh-huh.
and never ends.
So, yes?
I think they may have to create the API key.
Oh, they need to go to the,
I'm trying to exactly.
let me see here.
Oh yeah, so it's ask API key.
Yeah, enter your, change password. Do you enter your password?
I enter, but then it keeps doing that.
Oh, it might be, let's see. So by default, the user, they don't have the API key created. They need to create. Okay, if that's the case, let's do this. So you go to the D2S website, D2S.org, and then log in using your account. Go to PS2, and if under right here, click your profile, and under your profile, there should be a token or something. Let me pause my screen so that I don't expose my token. Okay, so I'm going to click my profile. So here, do you see this like API key? If not, you can click to create an API key. You don't have to copy it, but do you see this one, like the API key?
But I don't. I have the example. I have to request.
Yeah, request. So basically, create an API key, so later we can stream the data. So I'm not sure if by default new users don't have the API key enabled. Just create, and then once you are done, you can come back to here. If you're already in Google Colab, click the button to stop running because it might keep asking you the password if it's not working. So what you can do here is to, let me show here, click this, and yeah, make sure you change this one to your password. Let me enable. So change the email to your account password, and then click run this one from here. Then enter your password. So hopefully it works after you create the API token. Oops.
So, Qiusheng, one thing that I found out is if you for some reason ran the code without changing your changing email, this OS environment D2S email set to your email.
Oh, I see. I now it's.
It's not. It is only set to yours, so they're not changing it.
I see. So what you can do here, for example, right now, right? Accidentally you get like this, and it keeps spinning and then not working. You can just stop this one. And what you can do is go to runtime, restart section. So in that way, you can change that to a password. So I can click restart section, and then you come back to here, run again. Make sure you change this one to your email, and then if I run this one again, now I can enter my password. So, oops. What's if not? Oh, the reason for that is when I run it on my local computer, it will not ask me. Because I already set those on my local computer, so it will not ask me to enter the username and password. You see, now it should work, right? Yes? If it's not working, let me know. We can fix it. But you need to have that fixed. Otherwise, it won't work. All the data, you want to be able to pull any data. Okay, and then after that, just run the second one, the one beneath, to get the API key automatically. So you don't have to copy the API key from the website. Okay, any problems? Yes?
I'm not able to, it's still showing the error even if I enter my...
Yeah, just enter the account that you created with D2S.
Yeah, this is the one.
Uh-huh. Oh, and then you need to run this one, and then run this one, and enter your password, see if it works. Okay, anybody else?
Sorry, my password, I click enter.
Oh, you need to change your email account. Restart runtime. Restart section. Yes. Yeah, change this one to your email. Yeah, and then run this one. Yeah, make sure you change the email to your own email. Otherwise, it's not going to work. Uh-huh.
I changed my email.
Oh, then you hit enter.
Oh.
Yeah, oops. Let's see. I think you can just restart the... Yeah, and then enter the password and then hit enter. Yes?
Even if I enter the password,
Uh-huh.
so, okay.
No, no, do you hit enter after you enter the password?
No. Okay. So it's coming again for the password.
If this is the case, just restart the section. And then go here. And again. Yeah, enter again and hit enter once you're done with the password.
Okay,
No, enter the password and then hit enter.
I did enter the password.
So it's not working?
It's coming up same.
The API key issue.
Do you create the API key here on the D2S?
Yeah, I tried to. I'm here. Here. So if I issue the API key, I need to use that?
Let me restart the section.
In my case, I did not do anything with API key.
Yeah, you should not need, like, just try it again, enter the password again.
So it directly worked for me.
Yeah, I don't, some new user, I don't know it's what.
Yeah, it's the same.
No, the password is the D2S account, not your email password.
No, not the email one. So you can see this is the
Uh-huh.
password for D2S.
Uh-huh.
I just copied it from here,
Okay.
right? I copied.
Uh-huh.
Then I am gonna paste it here.
Mhm.
And enter.
Are you sure there's no typo or anything?
Your email.
Yeah, that's my email.
So what I recommend is you log out from here, see if you can log in again. I'm not sure if that's the correct password or not. Yeah, try to log in again. Anybody else having issues? So if you can pass this step, then run the next code block. You should be able to see the project here. If you cannot see anything, that means your account is not having access to the account. You might not see so many projects here, but you should have at least one or two if you're in the previous section. So can you see the list of projects listed? Yes? Okay, so this is where you can query the project. So basically, earlier when we log into the D2S, we're going to create the workspace. And then under the workspace, we get all the projects. under your account. And after that, we're going to print out all the projects under your account. And you want to see the list of projects here. It's a little bit too much. But you can also filter by title. So if your project has certain keywords, you can filter it. For this one, if you want it, we're going to use the Citrix. You have already been added to the project, to the team, so you should be able to see this one. If not, let us know. We can help add you to the project. So you can all see this project? Yes? Okay. And so here, basically filter by title. There might be multiple projects. After that, we're going to use the first one. So if you run this, we're going to assign to the project. So basically, if we have multiple projects return from the result, we're just going to use the first one. And after that, you just run this code block. We're going to get the project boundary. So this is basically the one that when you create a new flight, new project, you upload the GeoJSON file or the bounding box. So this is the project bounding box. So just show you the coordinates, something like this. And later we can actually map to that location. Under each project, we have flights, right? So you can have different flights, different dates. It can be multispectral, hyperspectral, LiDAR, something like that. So, and these are all the codes to get access to the data programmatically. And if you run it, also by the way, if you want to use a shortcut, so in Google Colab, it should be Control Enter, Shift Enter, or Alt Enter, but you can just click the button on the left side to execute it. It's the same. So for this one, for this project, we have two flights. One is June 9, the other one is December 15. So we have two flights for these projects. And you can also see the RGB here, the sensor, everything. So this is basically like when you create a project, you enter the flight information like that. You can also filter by date. So in this case, we have two flights, right? And we can filter by date. The start date is, for example, June 1st, and the end date is July 1st. So that means basically we want to select this flight. We have two flights. We just want the one in the summer, and just run it. Now it's only returned just one project, one flight. And after that, we can grab the first flight. It might sound like really why we are doing this so many steps, but I'm just showing you how to create data programmatically. But for the same thing, you can just go to D2S, you can just click, you can select, but that's not the point. If you need to process the data automatically, you don't want to click the buttons. You want to ask the computer. So technically, right now, we are running it step by step, but I can run it all in once. I don't do that, okay, because it's going to take a long time. But you can go to the Colab here, and one time, you can run cell and below. So you're going to run everything all at once. So then you don't have to click one by one. But it's good for teaching, so you know step by step what it's doing. And once you filter the flight for the summer, then we can get that first flight. Like I said, this is right now only have one, but you might have multiple. You might have one June 1st, July 1st, August 1st. You might have multiple flights. So right now, we're just getting the first flight. So this is the one here, June 9. And you can print out the data product, right? So for each flight, you might have also mosaic, or you might have DEM, you might have DSM, you might have LiDAR point cloud. But we can print out all the data products. So you can see here, we have a lot of data product here. And the data type, you can see also, you can also see DSM and also the CSM. So we have 3 products for this particular flight, right? 3 data products. After that, we can filter just to that particular one. So for example, we just want the also imagery, then we can filter by data type, then it will just return just one flight, right? So basically, you are doing that on the website, you are selecting stuff under the hood, is executing all the source code. So here is basically under the hood, the source code used to query the data. And that's it. So for example, we have queried this also imagery. Now we can visualize that. So you can run this code block. Hopefully it works for you. You see it's going to be creating the map and then zoom to the map and then load the imagery automatically. This is very much similar in the previous section that you can load the data in QGIS, but we are doing that here in Jupyter Notebook environment. Question? Yes? Oh, you have? Okay. So anybody else can see the imagery? No? Oh, so you start a section. It might saying that the leaf map is not available or something. Then you go back to the previous one where you maybe use the on the left side here and go to, I think it's like import the library. So go here, click this import leaf map, because if leaf map is not available, then you cannot do it. So click this one, import leaf map, and then go to visualize awesome imagery, and then run this one again. Hopefully it comes up. Well, it's taking a lot longer. It might be too many people like using the server. Oops. Let me see. None type is not available. Interesting. Okay, you might need to try again. Sometimes if too many people, it might be too many visits, so it doesn't work.
I ran that, but still I can't.
Let me see. Anyone can see the imagery? Nobody?
So it brings up a map, but it's not zooming into that layer.
Let's see.
I can't see that.
You can see the imagery? Does it zoom to the map?
I didn't do anything.
That's interesting. It might be a little bit slow. Let me try here. Okay, so let me try here.
Sorry, I cannot see this one.
You cannot see the imagery?
A little ahead, I saw another part,
Uh-huh.
which was the screen, but not for this section.
Section timeout. Okay, so you can see the map, but it's not, the imagery is not loading. This is interesting, kind of different behavior. 1 second, let me do a quick OS stock. So let me see the. Yeah, I think one of the reasons might be Google Colab is having a little bit different behavior. Let me find out the center of the location, and then we can.
Your notebook is working, but Google Colab is not.
Yeah, it's not supposed to be. Center.
I think it is located in West Laco.
Yeah, so let me try it, and we can fix it. So here, center equal to this, and then maybe zoom level equal to 14. Let's see if it works. Oh, okay, you can see it's here. All right, so let's do this. You can, in the map here, just type the center and then square bracket, and then you can put like the rough estimation. The maybe this put zoom 16 or something, 17, whatever. So try this. It's loaded, just not automatically center to the map. So try typing this one, center equal, and then square bracket. In here you can put just the latitude 26 point. You probably don't need all the digits, maybe 3 or 4 digits should be fine. 26.1659, comma, and then negative 97.9556 or something like that. And then zoom level 16, 17, 18, something like that. It should zoom to that location. I will fix it later. It was working. I don't know why Google Colab is behaving differently than my local computer. Okay. Anybody else can see the imagery now? No?
It zooms in,
But the image doesn't show up. This, you can see the imagery? Yeah, it's not instant, so it's like pulling the data, so you might need to wait a couple seconds. But if somebody else can see it, that means it's working. It might be just the Thai server, like too many widgets, so sometimes it's not getting the data like quickly, so it's like blank, but it should load up after a couple seconds. If after 1 or 2 minutes, if it's not working, you can try to zoom in or zoom out a little bit. Then it will trigger the reload. Yes? Okay. Yeah, okay, good to know.
Sorry.
Yes?
I can see the map, but the imagery isn't popping up.
Yeah, that's what I'm saying. It might too many people using it at the same time, so it's like loading. You can zoom in or zoom out a little bit. And this is all the server on the Purdue University server. So the T-tiler is basically just the middleman to render the tile. So you can think about here, the imagery is on the D2S server, and then you are here, and there is a middleman here called the T-tiler. It's basically rendering the tile needed for your client. So this middleman cannot handle too many people simultaneously, so sometimes it might not function. But if some of you can see that, that means you're the first one to get into the door, then you get the stuff, and then other people can also try to render the tiles. Okay. If you after 1 or 2 minutes still not working, then you try to zoom in, zoom out, or even run the code block again to see if it works. So this is how we query the data. Like I said, it should zoom in automatically. We don't have to enter the coordinates, but it looks like there's some like bugs in there. And so similarly, you can render all other data, for example, the DSM. So this just filter the data by the DSM. And then I can do the same thing. I can add the layer, the DSM layer to the map as well. After you run this code block, if you go up here, I should be able to see the DSM render on top of the also imagery. So if you zoom in, you should be able to see the data. So this is using the color map. If you want, you can click the button here, upper right, and this is where you can change the data layer. I can change the slider, so you can see the also imagery beneath. You can see the DSM on top of that. So it makes it really easy for you to see the data. Anybody else can see the DSM? Good. Okay. Cool. So this is the DSM, and not the DSM. This is the this is the DSM. But we also have the height above ground data here. You can also run this one Cox stacks. So basically shows you the statistics of that imagery. You don't necessarily need this, but it's good to know, for example, what's the elevation ranges of the DSM. So you can see here the minimum, the maximum, something like that. So sometimes if you want to add a color map, so the color map basically is the color bar. If you run this code block, it should generate this one at the bottom here, the lower right corner. So this is the color map, the color bar, shows you the elevation, basically the DSM, the height from, for example, 3 meters to 30 meters, something like that. Yes?
When I do the cog stats, I get an HTTP 401.
You try to run again. Like I said, it's just the server. The middleman is to be.
It's unauthorized?
Not unauthorized. It just basically means it doesn't handle requests. So if it doesn't work, try to run that one again. That one doesn't affect the usage, so if it doesn't work, you can ignore it for now. When after the workshop, when not many people are using that, it should be a lot more smooth. So this is the DSM. Similarly, you can visualize the CSM. CSM is the canopy height model. That means the DSM basically is just the digital service model. The height above ground canopy basically means just the height. So you remove all the underground. So they're going to show you the height of all the vegetation in the area. And very much. Which one? Oh, the height. So there might be some like the 30 meter. This is the DSM. So it doesn't mean the height because if you grow on a tree in here, you need to add the height above the sea level. So it's not just the height of the tree. So that's why it's so 30 meter. It's not exactly 30 meter, right? So right now, if I stand at the top of the building, then my elevation will be my height plus the building height, and also above the sea level. And this is the CSM, so the canopy height model. If you run it and do the same thing, add to the color bar, now you should, it's not coming up? Okay, it's coming up. So now this one you're seeing, this is the real height, okay? You will see it's from 0 to only 12 meters, something like that. This one is just the subject, everything, the ground floor to visualize the data. Oh, there might be some like artifacts or something like that. So the height is the maximum. So there might be a couple pixels, but it doesn't mean that it's all 12 meters or something like that. This is not soybean, so it's tree. So it's certainly much higher than just other crop types. Yes, there was for the wheel. And like I said, you can click the button here, upper right. So you can change the opacity, so you can compare the differences of these different data layers. No problem.
And you're a person also developed the GeoMap.
Yeah, GeoMap, yes.
Okay.
Do you use that? And yes, you can also add a GeoJSON, the project boundary. Yeah, of course. So if you run that one, it's going to add this, the yellow box here. So the yellow box is the project boundary that we are going to work on, how to extract the data, so we can use this bounding box to grab the data from the D2S platform. And what else? So get layer, or we can download the tree boundaries. So if you run this one, so now if you zoom in, so this might be a little bit hard to see. You can click this button to minimize the box, and so I can turn other data layer off. So this one right now has the light blue, so it's not very clear, but you can see the tree boundary. So this is, for example, delineated manually or using the QGIS plugin or something like that. So assume that you already know the location. So later we can use this one to train the model. Basically, you already know these trees, you already know the bounding boxes, and then you want to delineate these boundaries for other locations that don't have the bounding boxes. Then we can train the model to actually automatically delineate the bounding boxes. So this is, think about the input data we're going to use later. So like what we did like in the previous section, using, we didn't cover that in this one. It's from yesterday. So basically you can think about, you can either manually delineate or you can use other program that you delineate the boundary. But we're going to use AI to train, and then we can get the boundary by ourselves if needed. And so that's for the imagery for the summer, but we also have the other imagery for the winter, right? So you can do the same thing. It's the same step. So this is December 2022. Then you can run this code block. We can compare the imagery. This is very much similar to earlier using the D2S. You can see the split screen, but this one is using also the split screen, but it's a little bit better because you can use the slider. You can change it, so you can drag the slider to compare the imagery from the left to the right, right? So you can see how they are growing, right? During the summer, it's not after 6 months, you can see the changes of the trees. So just slide it. Also, you can click the full screen button doesn't work in Google Colab. So you also on the right here, you can turn the layer on and off if you need it. So this just provides you a way to easily see the data from D2S. And also, let me run the second one. So next, we want to download the data so we can start doing some analysis. So what I want you to do is to just run the next couple blocks because you're going to download the imagery from D2S. It might take a couple minutes. So just run the next couple code blocks to download the imagery. And one. Is it? Oh, because I already downloaded it. So if you're running this code block, it might take a minute or two to download the data. So just let it finish. So we're going to download the two imagery that we see from the split map here. We are going to download these two imagery. So these are two imagery that we're going to use to run the AI model. And after we download the model, we're going to extract a small area because for the larger area, the GPU is not enough. So we're going to just do, after you download the imagery, we want to clip the imagery to this small area. Then we can run AI models just on these two area. And yeah, just let it run and finish. Maybe you can take a couple minutes, but don't wait for too long because the Google Colab will be idle, then you'll be disconnect, okay? So you can take 2 to 3 minutes break, and once it's done, we can come back, we can continue the next step. If you want, you can run all the blocks until this segmentation. So finish all the blocks above. It's going to clip the data, and then going to show you, okay, this is the data we're going to work on. So you can see we have a small subset of the data. And then we are ready to move into the next section. Any questions?
Sorry, which section did you stop by?
Stop by here, before the automatic segmentation. So basically, we have all the data preparation done. Then we can move into the analysis part to do the segmentation. If you have any problems, let us know.
No,
Other
no,
than that, maybe, otherwise take 2 to 3 minutes,
yeah.
and then we can continue. Yeah, take a short break.
Okay.
But not too long. Like I said, Google Colab, we got disconnected. Then you have to rerun.
Let's take 5-minute break.
Mhm.
So this is 11 right now. So we're going to come back and start 11:05. Don't go too far.
Mhm.
Because not that we will have to start at 11:05. We only have a 1 minute.
Anybody finished downloading the data? No? Okay. Because the data is like 800 megabytes. So like I said, the server might not be able to handle all the concurrent downloads. You done? Okay, cool. So this is just for using the Citrix data, but like I said, you can create your own file, upload your own data. You can use the same work. All right, let's continue. So what you need to do is download the data and then just clip to the AOI, the region of interest, want to use for the AI. So just run all the core blocks until this one above the automatic segmentation. So it's going to clip all the imagery. On the left side, we click the folder icon. That wants to show you the data downloaded and also the one clipped to the bounding box. In here, I can also show that on my computer. So it's able to see all the also imagery, the one that have been downloaded and also clipped. If you don't have the data, then you won't be able to use the image segmentation functionality we're going to cover. Okay, so everyone has the data downloaded, clip? Not yet? Or still downloading?
I have. I'm done.
You are done? Okay. Maybe I'll wait for another minute or two. If you already finished downloading, then just click the next couple blocks to clip the data to the area of interest and then resample the data. So we're going to have two data sets for the summer and also for the winter, where we have two imagery. And the original imagery is 1 centimeter resolution, 800 gigabytes, so it's too much for the image segmentation. And that's why we resample the data here to resolution 0.1. That means it's 10 centimeter. So we basically downsample that to a small coastal resolution. So it's going to run faster. But if you have larger GPU, we can use the original resolution. But we're using 10 centimeter for the image segmentation, for the same segmentation. Then we're going to use the 2 centimeter for training our model. So when we are training our model, we can use a little bit larger imagery. Okay, are we done with downloading? Clipping? Still no? Raise your hand if you're still waiting. How many people? Just one? Okay. How many minutes is it taking? Okay. So for those of you who are already finished, then you can move to the next section. I don't want to wait for too long because the GPU we got disconnected. So you can just run this code block to import the library. The SAMGeo is a package that can apply segmentation model on the imagery. I created this one maybe 2 years ago. It has two versions. The SAMGeo is the version 1, the SAMGeo 2 is the version 2. So we can use both of them in this notebook. Once you import the library, then we need to initialize. And basically, we're going to create the model, then we can apply the model on the imagery. It's pretty simple here. So you just run this one. The model ID, so we have multiple different types of models. So this one is the larger model. The larger, usually the better, but it needs more computing resources. If you don't have enough GPU, then you can use the smaller version. But it's enough for this Google Colab. So we're going to use the automatic segmentation. Just run this code block, okay? And we need to download the model from Hugging Face. So I already did that, so I don't see the progress bar. But for you, you should see the one downloading the model from the internet. And so basically the model, you can think about the model is just the weight. And so the model is, you can think about it as like a black box, okay? So it's going to put in here, and we have the imagery. The image is going to passing through this model and then generate the output. That's it. And you don't have to worry about what's in there. It's called segment any model. So basically what it does is give the model an imagery. It's going to segment the imagery into different objects, different regions, and then just give you the output. And you will see the result shortly, but that's essentially what it is. It's a so-called foundation model that you don't need the training data. The model will be able to figure out which pixel belong to the same object, depends on the color, the texture, and everything. It's very powerful. So it's a model that's very popular in all kind of downstream domain. We can use for geospatial. People use it for medical imaging, finding tumor or whatever, like in the imagery. So basically, it just mimic our human vision. When we see something, like for example here, I see all the people. The model will be able to figure out like individual object, but the model doesn't tell you what it is. It just shows you that it's similar. This pixel is similar to the other pixel. That's it. It doesn't know it's human or tree or anything. It has no information. But we can train the model to do some post-processing to get the information if needed. Okay, are we done with this code block? Finished? Okay, now we can move to the next one. Generate. Oh, so just call the model generate, and we're passing this 10 centimeter resolution imagery that we just finished. And just run it. And this is where you're going to see it's going to take only a couple seconds. But on Google Colab, you can click here, and you should see the GPU RAM. That one should spike because it's loading. So when it's running the inference, it's loading all the data into the GPU, and then run the inference, and then we can get the data out. So the GPU is like very powerful. If you don't have that, it's very, very slow. It's usually 10 times slower. So how much RAM is it using? If you click that one, 2.7 or 3.7. So the model itself is like 2 gigabytes. So 2 gigabytes is the model, and you're going to generate the output. So the output depends on how many objects that you have. It's going to also use some GPU RAM. So in total, if you only have a couple, that means we have enough GPU to handle that. And so once you're done with the segmentation, then we can save the mask. So the mask basically means the result is the mask basically is individual object. So just run this one and then just show the mask. You should be able to see something like this. Okay? Yes? Good, right? So right now it's just a grayscale imagery. It doesn't really show you anything, but you can see the boundary, right? Object. So from the lighter color to brighter color, and it's just a grayscale. So basically it has a unique ID. You can think about from 1 to as many of the object you have. For example, you have 1 object, that means the value going to from 1 to 100. And do you notice any pattern here? The brighter color and the lighter color. Do you see any pattern? Brighter color like tends to be bigger. Lighter color tends to be smaller. So basically, the unique ID ranks the size of the object. So when it's giving the ID, the smallest object giving 1, 2, 3. The brightest object here, maybe I would say maybe this one or somewhere here. I don't know exactly. But that one is the brightest. Basically, the ID is the largest. So it ranks the size. So it gives you a clear idea about what it is. And this is the grayscale, but you can also generate kind of a random color. Like I said, right now you see all these objects. It has no idea about what it is. It doesn't know. It's just saying, okay, this one is similar. This object or these pixels in this location is similar. So that's why it's being grouped into the same objects. And you will see this, but right now you have the random color, but it would be better to overlay the result on top of the original imagery. So this is what we use to do the segmentation and also have the result. Like I said, it's not perfect. You can see all kind of problem, right? It means all kind of trees, but it does detect some of the trees in there. And this is like the normal process when you're doing AI. It's not going to be like one shot and then get a perfect result. No, you need to fine tune the parameters to get better result because it's a foundation model. It can do everything. But sometimes if something can do everything, it can do nothing. It's like, it's very generic. So that's why I'm going to show you later how to adjust the parameters to get better result. But as you can see, this is AI, right? So now you know how to use like the model, the couple lines of code, give me the imagery, pass into the model, get the result, and then visualize them on the map. Very simple, just a couple lines of code. You don't have to know like how it really functions. You just know that I want to segment object. This is what I want. And also you can just compare them. So if you run this code block, so if it's working, yeah. So you might need to run that 2 times. If it doesn't show up in the first time, you can run it, click 2 times. And this one shows you kind of the slider. So you can see the output of the imagery and also the original imagery. You cannot zoom in and zoom out, but at least you can see how good it is. It probably means maybe, I would say 40% of the trees, right? But it does have some objects. So the model does a pretty decent job, not perfect. So next we're going to load the data on the interactive map. So if you run this code block, it should have the imagery and also the object. So this one allows you to zoom in to the original data. So it's 10 centimeter resolution. It's pretty good, right? So you can zoom in, you can see all the random color. Like I said, the color is random. The color doesn't mean anything. It's a random color. So if you want, you can click here, click this, and you can turn the layer on and off. You can change the opacity to see how good it is. Not so good. It just does detect something, but it means a lot of others. So if this is just the initial result, if it's good enough, you can convert that one to a vector. So just run this raster to vector. You will convert the raster to vector because if you're trying to count how many trees, what's the average size of the trees, and what's the tree height, something like that, the raster doesn't tell you information. So that's why we need to convert to a vector, and then you can add the vector to the map. So now if I run this one, you see here, right? Now if I hover my mouse, you can see all the yellow boundary. So this one right now is the vector being converted to vector. Basically GeoJSON or Sapphire, something like that, allows you to run statistics on the data if you want to. So this is kind of general steps from downloading the data, do some data preparation, clipping the data, or resample the data to a coarser resolution, passing into the model, get the result, and then run some visualization. If it's good enough, then you convert to your final output that you want. Either it's a raster imagery or it can be a vector data set. Okay? And yeah, that's it. You see how simple it is? Like a couple clicks, then you get some preliminary result from the model without having to understand like what exactly is a segment anything model. Like I said, it's a foundation model. It segments object into anything. Group similar pixels into the same object. Any questions? So this is the automatic one. It doesn't look very good. That's where we need to so-called fine-tune the parameters to customize. So earlier we only use like maybe by default it's 32 and also the threshold. So think about here. In the result that in the previous one, it missed a lot of trees. So how can we improve it? So that means the initial rounds, probably your criteria is too high. That's why you miss so many. So this is called omission error. That means we need to reduce the omission error. But there's a balance between omission and commission. You need to find a good balance. If you're too relaxed, you find too many. If you're too restrictive, you find too little. So we need to basically try a couple of parameters to find the optimal one that can detect almost all the objects. And I've tested it, so these are some of the parameters we can customize. Like I said, you don't need to understand all of them. It's just if you want to look into documentation, there's help documentation showing you what does each parameter mean. If you have your mouse in Google Colab, it got disconnected. If you have your mouse on the function, it should pop up help documentation. But in here, you can see all the details stuff. It can get quite technical, but you can just run this code block. It's going to recreate a new model using your fine-tuned parameters, and then we can use it to do the same step to generate the mask, and then we can show the mask. So this one, you can see, it takes a bit longer because we make adjustment to the parameters, especially, for example, for this one, points per side, 64. By default, it's only 32. So what does the model do is that you give me an imagery, and then it's going to put like rectangular grids into the imagery. And then it's going to, based on each grid, it's going to find a similar pixel, group it in, and then into the same object. But in this case, we put 64 instead of 32. That means you have a higher density of grid. That means you're going to get more objects. And this is why later we get better result. But the more points you have, it's going to take a little bit longer. It's a normal process. And once you have that, then we can show the mask. Take a look. Now we get a little bit more, right? So we have a lot more objects compared to the previous one. And I can now also show the imagery on top of the original data. Now you should see a lot better. I think almost all the trees have been detected, but you can certainly see there's some like artifacts. For example, in the upper left corner, the long elongated one, that one is not really. But it's not the fault of the model because the model classifies all the objects into the same one. But the background is being removed, so you don't see the other like background being connected. But also at the bottom here, at the bottom center here, you also see some of those being misclassified as the trees. They are not really. So this is so-called the commission error, that you are classify something that's not supposed to be. So this is false positive. Earlier we have the false negative, that we missed too many. Right now we almost cover all of them, but we have some accidentally being misclassified as the object. And similarly, you can do the comparison if you want here. So that you can see the compare the imagery side by side. Oops. Like I said, this one has a bug, so you might need to run again to see the data. Okay, still not running. If it doesn't work, don't worry, it's not essential. So the next step, what we want to do here is called region groups. And so for this one, you can specify, basically filter the object. The model detect all these objects. It might be have some very small objects, some might be very big object, or some might be very elongated, like doesn't look like trees. Then we can do the region growing. So region groups, that means you're going to calculate some geometry property for each object. So later we can filter things out. So for example, if they're less than 10 square meter, it's not likely to be the tree, then you can remove them. So this is what the region group, you can specify the minimum size, for example, 10 pixels, and the maximum size is 2000 pixels. You can think about here, 10 pixels, the resolution is 10 centimeter, right? 10 centimeter by 10 centimeter. So it's 0.1 by 0.1, so it will be 0.01 square meters, right? So 10 pixels, that means it will be 0.1 square meter. So makes it, you can, depends on the object you want to detect, you want to adjust the size for the object. And just run this one, it will do the region groups. After that, it's going to generate a mask, and we can also add the data. So now zoom in, see here. It might not be super clear because the color is kind of a little bit hard to see. But if you have your mouse, look at this. We detect pretty much all the trees, individual one, and now you can count how many in there. Instead of manually having to delineate by yourself, this is so much faster. And as you can see, it only takes a couple minutes. Load the model, calculate the imagery, passing into that, generate the output, do some post-processing, and then generate the vector data set. And if you have your mouse on each object, and this is where the region group did. So have your mouse, you can see this is the label, the size. So the size is the area is the number of pixels. And you can also see other geometric properties, bounding boxes, the eccentricity stuff, and the extent, the orientation, perimeter, and also the intensity, all the stuff. So those are information that is useful when you need to filter the object. So for example, I know there will be, or that one might already be filtered out. I think the one in the upper left corner, oh, it's already gone because I set the minimum, the maximum size 2,000 pixels. So that one is just too big, so it has been removed. But there might be some here at the bottom. There's some of the tiny one here. Some of those you might need to manually remove them later if needed. And this is how you can use the model to quickly extract information. And as you notice, we didn't use any training data. All we need is just the imagery, that's it. And we didn't tell the program like what those are. It will automatically detect all the objects for you. But if you already have some training data, you already know like, okay, roughly, okay, this is the bounding box of the tree. Then we can use the model to look into the bounding box to give you a precise boundary of the trees. So this is what we're going to do in the next step. We already have the bounding boxes. Now we want to get more than just the bounding box. We want to get better results. So the same model allows you to provide the bounding box as the input. So now instead of just the one imagery, we're going to have one imagery, we're going to have the bounding boxes, and then we're going to output the mass, the tree mass. And that one is going to be so much better because you already provide the approximate location. So it's going to get you better result. And it's going to reduce the commission error. So you will not detect any object that you don't want. So let's just try this one. So run it. And we're going to use the same thing, the 10 centimeter. We're going to convert the bounding box to geodata frame. And then we can take a look at the data, see what it looks like. I want to show you the input data before we run the model so you get an idea about what it looks like. So for example here, these are the few boundaries that you already delineated from other program or manually or using other model, whatever. I assume this is what it looks like. But you can certainly see, right, we have the bounding boxes, but the tree extent doesn't really align with the bounding box. The bounding box is the approximate location. So what we want is to, for example, I want to calculate the total coverage area of all the trees. Then you don't want to use the bounding box. That one is overestimate the area. Now we can use these two inputs to get better results, precise results of the coverage area. So very much similar. Now we're going to use the same model one here, automatic. Very much similar to the same two, but the same one allows you to get a bounding box. And so we're going to create the model and then set the imagery. Set the imagery means, okay, you have the imagery, you have the bounding boxes. I'm going to use the model to actually classify, segment this imagery, and then I'm going to give you some bounding boxes telling that find the object within each bounding box. And let's see what we get. So set the imagery. After that, all we need is just one line call, predict. So the predict means I already know this is the imagery you're going to work on, and then when we're trying to do the predict, I give you some guidance. So the guidance is like I give you some bounding boxes. And this is what this is here. This is about. I give you the bounding boxes. You are going to follow my guidelines, my instructions to extract the object. And the point coordinates 4326 because it's the WGS 84. And that's it. Just run it. And it want to tell you some of those might be outside the boundary because you might have something cross the edges. And that's it. It's done. Now you just run this one, add the imagery, and zoom into here. And now take a look. So just with a couple lines of code, we go from the imagery and then giving the bounding boxes. It might be like buffering. It might take a couple seconds, but you can see how good it is. So you can change the color. So what's this color? Brownish color, right? So now, is it better than the bounding boxes? Yes, right? It gives you precise boundary of all the trees. So I can change the opacity to a little bit smaller. And one nice thing about this is the model is pretty intelligent. You can see the bounding boxes, but the output actually extends slightly beyond the bounding boxes. So you know, like if you give the bounding boxes, you're going to find the largest object within the bounding boxes. Even if the tree extends a little bit, you'll be able to find the object, all the pixels belong to that bounding box, belong to that tree. And so this is what the result that you get. And certainly this one is, oh, there's still some missed pixels, but overall this is much, much better than the automatic segmentation, because automatic segmentation just give an imagery. It doesn't tell you what you want to extract. It's just trying to guess the largest object and then remove the background. But this is what you can certainly use if you already have some like rough training data, some bounding boxes. You can do that using this way. And yeah, and after that, because this is already a vector data, so on the left side you should be able to see the output. So the output is tree mass, and also just the raster. So you should be able to see the imagery here. On Google Colab, you should be able to find the one on the left side here. So basically the output is generated and then save it to your computer here. And if you want, you can download the data or you can copy to your Google Drive if you want to. Questions? Right, very easy, right? It's not many lines of code you need to write. Just create a model, point to the imagery, and give some additional guidance if you want to. Run the model, get the output, and then do some post-processing, save the result, and then you can use that to do all kind of analytics or statistics if you want to. And now we're done with the automatic segmentation. The next one I'm going to show you is actually doing more like supervised classification. That means we can provide, it's kind of similar to the bounding box I showed you earlier here, but it has more applications. So think about here, if you need to, let's say right now we have this, but if you want to segment the imagery on a new data set, new area, you don't have the bounding boxes, then you cannot do. Then you can use automatic segmentation, then you might end up with commission or omission errors. But we can train the model for this data set, and then we can use it to apply on other areas that you don't have the bounding boxes. It can still get the result. So this is so-called like transfer learning. Train the model here, applying a new area, new imagery, then you can still detect those objects, okay? And this is the one that want to use the GeoAI model here. So I want to import the GeoAI model. And earlier we already downloaded the imagery and also extract the data. So this is the imagery, and also we have this, the green bounding boxes here. What we are trying to do here is to use this imagery, use the bounding boxes that we have. We're going to train the model, and later we can apply to new area that we can delineate the bounding boxes for other data sets. So let me run it very quickly. We're going to specify some of the imagery we're going to use for training, imagery used for the testing. And we're going to use the June imagery for training, and we're going to use the December imagery for testing. So that means for the June image, we already have the bounding boxes, but for the December one, we don't have the bounding boxes. It might still be the same, but it might grow, become much larger. So we want to delineate the object. Then we can use one for training, one for testing, and also we're going to clip the imagery to a smaller area so they are consistent. And I don't have to really clip it because I have a larger GPU, but if you're on Google Colab, we are clipping the imagery to 2 centimeters. Because the original imagery is 1 centimeter, is 800 megabytes. If once you click to 2 centimeters, it's like downsized by like 4 times, so it's much smaller, so it doesn't run out of GPU. Okay, so we clip the 2 imagery to a smaller area, the same area. Then we can create a workflow to train the model. So if you're new to like deep learning or AI, this is the general workflow. So once you have the 2 imagery, you need to create so-called image chips, image tiles, because you cannot just feed the entire imagery into the model. It's basically creating into the overlapping smaller tiles, and then have one tile, one like mask, and then feed all of this into the model, and then you're going to train the model, and then you're going to continue to feed the imagery into the model until you get good results. So the first step here is to export GeoTIFF tiles. So that means we're going to cut the imagery into smaller pieces. So, and what you need to do here is to provide this input imagery and also the vector data. So essentially what we're doing here is I'm giving the model of this imagery and also these bounding boxes. It's going to convert the bounding box to raster because it's vector data set. Deep learning model doesn't really handle vector data directly. So convert to raster and then cut corresponding image pairs and then feed into the model, and all you need is just one line of code. So we create all the training tiles. It's done here. So in total, we have 288 tiles. If you want, you can click here. You should be able to see all the tiles in here, imagery, right? So TIFF tile 1 all the way to 288. So these are all the image tiles. So we cut the image, the drone imagery into 288 image tiles, and also the corresponding label. So the label basically is a mass of the bounding boxes. It should be the same. Once you have this, now we can start training the model. So we're going to use the UNet segmentation model. Once you have the image chip, you just point to, okay, these are the image chip I want to train the model on. And then you can specify the architecture. So this is where you can customize. Let me run this one first quickly. So because it might take a couple minutes to run, I would like to explain what this is doing. So basically, you have the data, then you need to decide what model you want to use to train it. Different from the segment anything model, it's just like one single model. You can just feed the imagery and then get the result. This one, you do need to select the model that you want. Different models have different performance, different applications. And UNet is a very popular one for doing image segmentation, but there are other models out there. And if you want, you can look at the help documentation. So you can select all kind of model, all kind of state-of-the-art computer vision models to do image segmentation, train the model. And you're going to print out all the outputs in here. It looks quite complicated, but what you need to pay attention to is this validation loss and also the validation IOU and also F1. So what this one is doing is when you train the model, you're going to give you the rough output and you see if the output is good enough or not. If not good, you go back to refine the model. So what you want to see is the loss is going to decrease, but the IOU means intersection over union. So intersection over union means your prediction, the overlap between your prediction and the ground truth. So the higher the better. So if it's 0, that means you're predicting nothing close to the ground truth. So for example, you're trying to detect the laptop here, and your result is like you have an object here. That means you have nothing related to this one. If it is 100% 1, that means you have a perfect prediction. And you can see the number actually is increasing. So in the first epoch, the first time you're training the model, you get like 66% over there. It's pretty decent. The reason for that because we use the so-called encoding weight. So that one basically the pre-trained weight is the in deep learning called pre-trained weight. That means they have trained the model on other data, and they already detect like some of the very generic patterns, and those are the so-called weights. Then we are applying this one to the so-called fine-tuned model for geospatial data. So we're going to use this very generic one, and we're going to apply something additional to that so that you're going to get better result. And this is why you can see it's increasing. So what you want to see is the IOU going to get closer to 1. The closer, the better. So you can see 0.71, 70%, and then it might fluctuate a little bit. It's normal because the final goal of the model is to get very low loss, very high IOU. And imagine you are going from the mountain top to the bottom, right? There might be multiple routes. So what you want is to find a shortcut to get to the bottom. And if you have multiple routes, you may go this way, or it's taking too long, you go back to here. So eventually it's going to converge and then get to the bottom. And this is essentially what it is. If you want, you can, you can plot the so-called performance matrix. And this is what it looks like. So take a look at this IOU, right? It's going to be very high, and then all of a sudden it fluctuates at the beginning because it's just getting started. It doesn't know where to go. But once you figure out, you're going to get closer and closer, and this is why it's increasing. So in general, you want to train the data for maybe 30, 50 epochs. To save time, I only train for 10 epochs. But you can see the pattern here. It's going to show you the final output, for example, the IOU F1 33%, and then the IOU 70%, the base is 81%. It's not bad. 81%, that means your prediction, the mass has 80% overlap with your ground truth. And if not good enough, you increase that or adjust the parameters. And that's pretty much it. Once you have the model, now we can apply the model to a new area, right? So we train the model on the imagery from the summer. Then we apply the prediction on the December or any other imagery. It doesn't have to be the same location. It can be other location as well. It should be very generic. So just run this one. Now I can do the semantic segmentation, right? You passing the imagery for the new data and then passing the model. So the model is the base model. So basically the one generated from here, all the model being saved to the folder here. If you click this unit models, if you double click, it should show you the two models. The base model is the one with the highest accuracy. The final model is the last one because you have 10 epochs. So each time you're going to save the model. And the last one is not necessarily the base one because it's fluctuating quite a lot. So you can see here, if you only train 10 epochs, you can see the last one actually decreased because it's trying to figure out the way to get to the bottom, get to the highest accuracy. So the highest accuracy actually is the one here, epoch number 8. So we're going to use this base model to do the prediction. And all you need to do is one line of code. Okay, now I want to apply the model. And under the hood, it's going to subdivide your imagery into smaller chips. And then going to run the model in each one and then combine the result as a single one. And that's pretty much it's done. Now let's visualize the data, see what it looks like. Okay, so this is the imagery for the December that we don't have the data, and we use the imagery from the summer and the bounding box to train the model. And now we ask the model to predict the bounding boxes for the December one, or it can be other region, other location. And this one is the probability. So take a look at this. So the kind of the red color, brownish color is the bounding box. And the blue color is the low probability. Then you can set a threshold to say, okay, if it's greater than 0.5, I'm going to extract the bounding boxes. And this looks pretty decent, right? So you can see here, this is the original one. And this is the bounding boxes that it generated based on the summer data. We don't have the bounding boxes for December, but you can still predict a pretty decent job. Of course, you need some post-processing. It's not going to be perfect, but there's not much effort. So if you want to extract features from something like this, you can do it very easily. And the imagery is being saved to the computer here. So all the data is being output into the result. So you can see here the tree, the output result here. This is where you save the data, right? Unit models, and then also imagery, the mass, and also the probability. Everything is saved to the folder. So if you want, you can actually look at the result and see here, right? These are the two outputs. And then you can log into desktop.js. You can do some post-processing. You can convert this one to vector, similar to what I showed you earlier, right? You generate the mass, and then you convert to vector data set. Then you'll be able to calculate the number of bounding boxes, the size of the bounding boxes, something like that. It doesn't have to be just the bounding boxes. Think about here. If you want the precise boundary of the trees, then you want to train the model based on the imagery and also the precise boundary, similar to the same bounding box output that I showed you earlier. If you use that one as the input to train the model, then the output will be the precise boundary. Because I use the imagery, use the bounding box, you're going to give the imagery and give it the bounding box. But it depends on what you want to provide for the model. So the better the input data, the better of the output you're going to get. So this is very flexible. And the workflow is the same. It doesn't have to be trees. It can be buildings. It can be water bodies. It can be anything. It doesn't matter. All you need is some input data. So I'm only showing you here, like you can try it out. But if you want to learn more, you can go to the OpenAI, GeoAI website here. I have tons of more examples in here. For this workshop, I only show you one application. You can use to do building detection, car detection, ship detection, parking lot, anything. You can even do text prompt segmentation. You can just say tree. You segment the trees. You don't even need to do that. We don't cover that here, but Certainly, there are a lot more examples here. So I recommend if you are really interested in diving into this, you can follow some of the tutorial here that I put out the notebook example. Everything is reproducible, so you can run it using Google Colab. And if you want to follow some video, there's also the video tutorial here on YouTube. So you can go to my YouTube channel. I have a lot of other YouTube tutorials showing you step by step how to prepare the data, download the data, train the model, and you can do all kind of object detection. Anything, it can be anything. As long as you have some imagery, you have some label, some mask, then you'll be able to adapt this one. And you can, not just for drone imagery, it can be satellite imagery, it can be some LiDAR data, you can combine LiDAR with air image, drone imagery, so there are tons of applications here. If you want to learn more, check out those tutorials. And let me see what else. Yeah, that's all I want to show you. Lastly, there are also a couple resources. You're welcome to explore more data on the D2S platform, upload your own data, and then do some visualization, then develop some novel examples to visualize the data interactively, run some of the data. Like I said, the workflow is very generic. Okay, you can adapt that one to your own data. Just change the file path, then you can run the same model, get the result. And if you run into any issues, you're welcome to post questions on GitHub. So if you go to the GitHub here, you can ask questions. People ask questions all the time. And when I have time, I will respond to those questions. But if you find any bugs, you can also open an issue on GitHub that I can help you out. Like I said, it's still under active development. There will be a lot of new features coming. So you can, in the future, you can predict, for example, canopy height, something like that. You can do prediction, not just for doing segmentation. So yeah, that's all I want to share. If you have any questions, happy to answer your questions. Yes?
So we are doing this with 10-meter resolution.
Uh-huh.
So have you tried with more 30-meter or even more?
Yes. So because these are very small objects, so that's why we have a higher resolution. But you can certainly use other satellite imagery, Landsat, Sentinel. I have other examples here if you want to try it out. For example, examples. You can do Sentinel-2, Landsat. It doesn't matter. It's just you can do whatever imagery that you use, from 100-meter resolution to centimeter resolution. Of course, for centimeter level, you need larger GPU because the imagery have so many pixels. For coarser resolution, you don't have to. And that is not just for satellite imagery. If you have some like JPEG, PNG, like computer vision, you can also do that. It doesn't necessarily have to be geospatial data, have geo reference. You can do with JPEG, PNG, like just a photo, and then have the mask. You can train the model as well using the same workflow.
So what would be the challenge with like hyperspectral data?
Challenges is the computation because you have so many more banks, right? So 16 gigabyte GPU was sufficient to run the example that we saw in this workshop, but if you have like gigabytes data that you want to run the model, then you need a much larger GPU. Otherwise, you won't be able to do that because all the data, the model itself might be pretty. So when you're training the model, the more parameters you have, the larger the GPU that you need to have in order to run those models. And say it again.
So that means we need more like AI workstation, like with a higher storage capacity.
Yeah. So what you can do, I would recommend that don't just dump everything into the model in the first try. Cut a small piece and then try it out, see how it works. And then you can slowly see what's the capacity of the model that you have, and you can monitor the GPU when it's running because you want to find out when the GPU is going to exceed, right? So let me quickly show you here. For example, I can go back to when I'm training the model. For example, this is when it's running. So you want to start with small and then slowly grow. Like for example, I can train 30 epochs and let it run, and then it's going to basically fit the model. But I can actually monitor how the GPU is running. For example, watch this N.5 NVIDIA SMI. So you can see how the GPU actually is consuming the GPU here. So right now you can see it's actually using two of my GPU for training. So this is fluctuating, right? 40%, 70%, it's increasing. So I have two 48 gigabytes. So I have 96 gigabyte GPU. I can run pretty large model training, but GitHub only give you 15. So you need to like make sure the size imagery is not too big so that it doesn't exceed the memory. Yes?
Are there any examples to run regression tasks?
Yeah, not yet, but it's coming. Like I mentioned, like predicting canopy height or other stuff. Yeah, it's on the to-do list. So it's here. If you go to the GitHub, I have a lot of things I want to implement, but there's only one person working on a project. It's using my free time, so I only have so much time. I would love to do more, but this is only one. If you go to the OpenGeo's solutions, I have many other projects in here. So GeoAI is just one, but when I have time, I try to implement. And in the next couple months, there will be a lot more new features. If you have any particular use case, you're welcome to check out the GitHub and then open a GitHub issue. And it's open source. Anyone can contribute. If you can write code, you're welcome to contribute code. There are some people already contributing, but I would say 99% is I'm the only one actually doing that. But we welcome all kind of contributions.
You mentioned that you can combine the image with LiDAR.
Yes.
Do you see any improvements? Can you also feel like NDVI or any other?
Yes, you can add any band. So basically, you can process data and then combine it with a single one. So let me show you here. I also have one, I think, train building. Let me see here, LiDAR. So for example, here I have a building detection using LiDAR and aerial imagery. You can follow the same workflow. You can combine, for example, the also imagery and maybe also the LiDAR for the tree height, whatever. And well, you can put them together, and you can run the model, and then you can do the segmentation. So I have some of those functions that allows you to combine them together. Let me see here. Stack bands. So this function allows you to combine here. For example, I have the aerial imagery, I have the LiDAR, CHM, whatever. You put them together as the input file. It will combine the imagery and then stack the band, and then you put this one into the model. It's the same workflow, just like your input data right now have multi-spectral bands. So you can add any VI, any WI, whatever you want into the input data.
Is there a maximum?
No, you can put 20, 30, it doesn't matter. But at the end, it's all based on your computing resources. If you have more, you can put more bands into it.
So if you look carefully, whoever has more data has the power to train this type of model. So the reason why we don't have that many AI application yet is because not so many people is opening up this kind of data set to do this kind of AI development. The reason why we have a lot of examples is that USGS has a nationwide able LiDAR data coverage that generates huge volume of data. Satellite images open to public. So going back to the initial the comment that I was making earlier, why we're doing data science, is we want people to contribute your data so that other people can use your data to use AI training. Just like you pointed out. Any other questions? Okay, then thank you very much for staying with us for value of 4 hours in the morning. Hopefully this was very helpful. And if you have any questions, you can look my name up or Qiusheng Wu's up. You guys can reach out with us via email. Thank you very much. Have a nice rest of the conference.
Thank you.